Hello, everybody. We are Team SCC. I'm Lang, and with me we have Ian, Clovis, and Enzo, and our team has chosen problem statement number one. So let's jump straight to the model explanation. The task of review classification requires models that are both highly accurate and scalable to large volumes of user-generated content. Our solution is a two-stage pipeline consisting of Nomic embedder and a modified Mamba-based decoder. We employ the open-source Nomic embedder as our encoder. The review tags are outputted as a sequence of dense vectors, while the location metadata is returned as a singular vector. Leaving the review text as a sequence of dense vector allows our decoder to map the relationship between tokens, allowing for a greater insight to be learned rather than just a singular vector. Our decoder is based on the Mamba architecture, which scales at O of n log n in sequence length, while transformer-based model achieve O of n squared complexity. This allows for a faster interference, and it excels at capturing long-distance contextualized relationships in sequences. Here's the overview of the Mamba architecture from its paper. As you can see, it only accepts a sequence input. However, the Mamba architecture details in the paper does not allow for a context injection. We overcame this through modifying Mamba selection function to using a feature-wise linear modulation selection function. This allows us to incorporate our location metadata into the input sequence selection function. As for data processing, we employed Mistress 7b instruct to filter and categorize reviews as relevant or not relevant that we scraped. At this step, our priority was to ensure a clean positive set, and thus we used prompt engineer to enforce a strict relevant criteria. Furthermore, since irrelevant examples are often underrepresented, we generate them synthetically using the same LLM. Using prompt variation and diversification technique, we generate the reviews for each policy while ensuring that there are variation in review formats. For the results, our model achieved a 97% accuracy and an F1 score, outperforming our baseline of a cross-attention transformer by plus 1% absolute improvement. Importantly, these gains were achieved while using fewer computational resources due to the efficiency of the Mamba decoder. So this is a demonstration video of how it might look like in application form. So at the top, we can see a input for a review and option to upload a CSV. So once the data is being inputted, the dashboard will show three things: a policy classification label, a relevancy score, and a confidence level.